Hi everyone, I will demonstrate you the nesting utility on Inventor 2018. I opened therefore an assembly which has a mix of sheet metal parts and regular parts. Some of these sheet metal parts have a quantity of 2, as you can see in the bottom. I now access the nesting functionality through context menu, decide to use a metric template file to do the work in, and on open we immediately detect only the sheet metal files. We see that there are 3 different materials with different thicknesses. At this point we're reading in the closed loops from those sheet metal flat, and you see on the left in the browser the shapes materializing. Each part is colored differently here. Just to prove that we are able to read in the bill of material quantity correctly, you see the 2's coming up. I'm changing some parameters at this point, like 45 degree on the blank insert, and I turn on the mirror on another part. We can display these special situations here with the drop down. So here I'm displaying the part with different orientation, for instance. I'm returning here to 1 color per part. I do a job quantity of 5 here to maximize my sheet usage in production. You see that there are 3 nests being created, 1 nest for each material. We also show the efficiency during the nesting process. And here is the result of the nest. So I'm showing here the 3 nests together and a different material per nest. So this nest 1, nest 2, and nest 3. You see on nest 3 that the parts are not all oriented in the same manner, so this might be important for you if you care about grain. So I'm turning off the rotation capability of that nest, and you see here all the parts are now oriented in the same fashion. You're not restricted to just using the assembly. You can also bring in individual IPT or DXF files. So in this case I bring in a DXF file, and I even change the units, and it is a centimeter file, but I want to bring it in as a millimeter file, which is basically a scaling operation. As you can see from the properties, I can also assign it material 2. And because I want to use it as a filler part, I change the quantity to 10. I recreate a second study with that extra part in there, which allows me to compare studies. And that's the interesting part of this software, is that you can compare efficiencies, for instance, or sheet composition by displaying the nests side by side. As this nest takes a while, I need to say that this is a multi-threading operation, so you could in principle do other things while calculating the nest. So here you see the result of the 2 nests together. I make the source files invisible, and I make some of the nest invisible so that I can really compare the first nest in the first study with the first nest in the second study. And you will see that that small filler part now got not only added, but also added in the holes of other parts. So very economical nesting here. And I can compare the efficiency by looking in the report. So here you have an efficiency of 64 something, and on the second study, which is hopefully better, you'll see that the efficiency is increased to 71%. So that's probably the nest that I will go with in production. I can also add different sheet sizes. What if I want to go, instead of having 2 sheets for the nest, I want to have 1 sheet? So I could bring in a slightly larger sheet size in the packaging, then edit my existing nest and introduce that new packaging 5, prioritize is put it first and say, for instance, that I want to use 3 sheets of that larger 2000 by 1000 packaging before I use the square 1000 by 1000 packaging for the remainder of the nest. So, and you will see the result here is that I will get less sheets. While it's calculating, apparently this operation might take a while. I could do other things because of the multi-threading. So I opened here the nesting properties dialog. I'm not doing anything in particular here, but once the nest has finished, he will tell me, do you want to save your current work before I generate the nest or not? So he clearly gives you the choice to finish the work that you were doing. Now I'm visualizing the nest results. So you see here I have a single sheet size because I'm using that bigger 1000 by 2000 packaging. At this point I'm happy with my studies, and I return for a second to one of the sheets that I made invisible because it's a slightly simpler sheet. And what can you do with these results? So you can export them first of all to DXF. So this would give you an opportunity to use your regular CAM software that you use in AutoCAD to do your production and your toolpath calculation. So we clearly give you that choice. At this point you can also start measuring and verifying dimensions. You have all the AutoCAD tools at your disposal. Another avenue for exporting this data is to use the Create 3D Model command from the context menu or from the ribbon. This generates an IPT file from each shape in the nest. We will create a body, an extruded body. This allows you to create an assembly of these results, or to do documentation in a drawing, or more importantly, to do CAM work. The latest version of HSM has a command called 2D profile that can be used for this. I'm setting up the part here with the origin in one of the corners, and I use this 2D profile command. I'm doing plasma cutting here. There is a curve width that might be interesting to set properly by looking at the separation in the material that I used for that nest. So I see that I have a 1 millimeter separation. I do want to copy that and bring it over as my curve distance on the cam side. So I'm reopening that 2D profile command, and I paste the separation in the curve width field. I have an interesting field to set, select same plane faces, because there are so many faces otherwise that I would have to select. So it's an interesting checkbox to certainly check. And here is my resulting toolpath. The toolpath can be simulated, and that is basically it. Thank you for watching, and hopefully you enjoy the beta.